Everyone. Thank you for coming to this LibPressio Spack C++ office hours. I appreciate everybody making time to come. And kind of to give you a picture of what we're going to be talking about today, we're going to start from installing Spack, kind of managing various things with Spack so that we can understand what it's doing and how it works, so that when or if things go wrong, you can kind of debug some of them and do things of that nature. So what I'm doing right now is can everybody see my terminal, or anybody cannot see my terminal?
Yeah, we can see your terminal, I think.
Okay. Okay. So the first thing that you'll want to do when you're installing Spack is you'll need to clone it. So you'll use git clone https://github.com spack. I already have a Spack instance installed on my computer, or on my Bebop account, that I'm having some difficulty deleting this morning. So I'm going to create a new Spack instance in a different location. But you don't have to do that. So once you have Spack cloned from GitHub, there's a couple of steps that you'll need to do in order to actually use it. So the first thing that you will need to do is you will need to source, there's a shell file in here, in the share setup, or share Spack setup env.sh. So what does this little piece of code do? What it's doing is it's adding Spack to your Python path, as well as your executable path. So you can now call the Spack executable. So Spack does a lot of things. Some of you may have used the module system in the past. So you might have said like module load something. Spack, in many ways, is going to build a system that is very similar to that. It was designed, in some senses, for supercomputing systems to build the set of modules that they themselves would ultimately use. But to be flexible, in order to account for all of the differences that different supercomputing systems have, it's important to be able to interface with certain vendor-provided dependencies. These can be things like BLAST libraries, OpenSSL, MPI, compilers, and that's kind of the first thing that we're going to set up. So the first thing that we want to do is we need to figure out what compiler that we need to use. And the way that we're going to do that is we are going to ask what versions of MPI are available in the module system. Okay, so we see a collection of different MPI systems available, and we can load one of these. So we could say module load OpenMPI this. And again, this gives us an error that says we need GCC 920. So we'll module load that first. And then we can then load MPI. And now we are ready to fully configure Spack. So the first thing that we'll do to actually configure Spack itself is we will tell Spack to detect compilers. So we'll say Spack compiler find. Okay, and it will say that it found 2 compilers and it added them to a configuration file. So by default, Spack will add compilers to your user configuration. So if we look at this file, we can see that it found GCC, G++, and G4tran for CentOS 7 on x86 targets for GCC 850. And then we can see that we found another compiler from the module that we just loaded. Now, there's a problem with this configuration. Specifically, the problem is you see this modules entry right here. So this modules entry needs to be populated with the modules that were required in order to use the particular module. So we're going to need to add this to this modules array. So you can either edit the file using your favorite text editor, or you can say Spack config edit compilers. And come out down here to your module line, and you can add the module to the list of compilers. Okay, any questions on what I've done so far? Okay. Hearing none. The next thing that we need to do is we need to tell Spack about our system MPI. Since we're using, in this particular case, open MPI, we will say Spack external find MPI, or excuse me, open MPI. Okay, and it tells us that we've detected the open MPI 4.1.2, but that's actually not all that we need to do. Much like when we told the system which GCC package we added, we also need to tell Spack about the MPI versions that we're adding. So we'll say Spack config edit packages, and then we can come in here and add a module prefix like so. And then we're going to remove the prefix entry. Okay. So now we can actually install packages using Spack. So when we're doing this, it's kind of important to understand and think a little bit about how Spack describes dependencies. So there's a couple of commands that you'll want to be aware of for doing this. The first of this is you want to be able to ask Spack what dependencies a package depends on. So you could say, for example, Spack spec zlib. And if you're doing this for the first time, what Spack will do is it will need to install a C++ program called Klingo. And what Klingo does is it's what's called a SAT solver. And if you're not familiar with what SAT solvers are, they solve what's called the Boolean satisfiability problem. It's a very, very fundamental problem in graph theory. It's considered to be NP hard, but it's fundamental to solving complex dependency trees. So that's what's going on here. We're also seeing a bunch of warning about Spack will not validate SSL certificates. That's because the system provided Python on the Bebop system is Python 2, whereas a later version of Python, Python 3, wouldn't support SSL verification. These warnings are not particularly concerning. Okay. And this process just takes a little bit of time, especially when the file system is being slow. So this is a good time to take questions if anybody has any questions on what's going on so far.
So Robert, I have a quick question. So it seems that it involved Python. Do we need to install Python separately?
No, so you can use whatever Python is available on the system. So it will even support older Pythons. I think the oldest Python it will support is like 2.6.5. So any Python installation that you can find that was created in the last 15 years should be okay.
So if the Python was not launched automatically, I still need to use the module load to install one Python on Bebop,
yeah.
Right? Okay.
Yeah, so in this particular case, there is a system Python that is provided on Bebop. So you won't need to load a module on this machine, but if you were setting this up on your home laptop, you would need to install Python and Python Devel, which is the development libraries for Python.
Okay, so the command Spack zlib is to check the dependencies of the zlib, right?
Yep.
So actually, it is not installing the zlib.
No, this is not actually, this is just checking the dependencies. So we could look at a much more complicated package. So we could say Spack spec openblas. And we'll see that there will be a much larger list of dependencies that gets generated.
So do we need to install the lib using Spack before running this command, Spack zlib?
No, you do not.
Okay.
This just queries the package database of the packages that are available. So for example, if we're looking at openblas, we can see that openblas with the configuration that we've specified depends on Perl, and then Perl depends on BerkeleyDB, bzip2, GDBM, and zlib.
I see.
Now, you may notice that a lot of these packages have little tilde signs and plus signs that come after them. Okay. These are somewhat important and much more important when we talk about LibPressio.
Because it had a lot of dependencies.
Yes. So,
no problem. Thank you.
Yes. So the next thing that we're going to want to do is we're going to want to add an additional set of packages to Spack for using LibPressio. So you can clone those with https github.com/robertu94 spack_packages. And I'll call this robertu94 demo. Helps to write clone. And then you'll say Spack repo add, and then you'll give it the path to that list of packages. Okay. If you're ever curious what a Spack package looks like, you can just look in this repository. There's a packages directory, and then under that are directories for various things. So this package provides things like CUDA dependencies. It provides things like dlib, fpzip, ftk, mguard, mguardx, ndzip, qoz, se3. So just versions of these packages that have been optimized for use within Spack. In many cases, we contribute identical versions of these packages back to Spack proper. But we kind of develop them and make our own changes locally here first. So if you're wanting to use LibPressio, you will need to add that package. Now let's look at the dependencies for LibPressio. So for those who are not familiar with LibPressio, LibPressio is a kind of a package that allows you to interface with multiple compressors simultaneously. So you can use SZ and ZFP, or SZ and mguard, or any combination thereof. You can even use lossless compressors like BLOSK to suit your particular needs. Now, when you see the list of dependencies from LibPressio in a moment, you're probably going to be surprised to a certain extent that it is as small as it is. Okay. Namely, there's no compressors that are listed by default. So if you want the actual compressors, we need to turn, these are called variants for LibPressio, on in order to enable the specific dependencies that we need. If we ever want to know what the list of possible variants are, we can use Spack info LibPressio, which then gives us human readable descriptions of what all of these various options do. Okay. So if we wanted to build or ask Spack to build a LibPressio that supports SZ and ZFP, you would say like this. And when this comes back in a minute, what we will see is that SZ and ZFP have been added to the dependency list. And then we also see that Z standard was also added. Okay. Now, some of you will also need specific versions of SZ. So if you wanted to depend on a specific version of SZ, you can say SZ plus stats, for example. And what that will do is this caret character right here, that's number 6 on my keyboard. This caret character in Spack means depends on.
Yeah, maybe I can introduce the SZ plus stats. What does it mean to other students? So yeah, in SZ, I think stats is a kind of a configuration, right?
Yep.
So yeah, so if you turn on this configuration, then you can check the specific statistics about this SZ compression. For example, the number of the condition beings, and you know, the Harman tree size or things like that.
Yeah, so it's a useful feature that you may want to enable. Depending on what you're doing, maybe you need the pastry version of SZ, which is a version specialized for quantum chemistry. Maybe you want to do temporal compression. Maybe you want to turn on the Python bindings or interface with Fortran. There are many options that you can potentially turn on here. And if you wanted to know about them, you would say Spack info as Z, and you would get a human readable description of what each of these various options do. But the important thing that I want to kind of indicate here is we see LibPressio plus SZ plus ZFP depends on SZ plus stats. If we compare the SZ Spack or the SZ spec that was built, we see that plus stats was added here, whereas the default tilde stats was used here. Okay, does this make sense? Okay. So another thing that we may want to do is we may want Spack to use OpenSSL from the system. So to do that, we could say Spack external find OpenSSL. And then we will see that an OpenSSL has been added from the system. At this point, we can choose to build a particular configuration of LibPressio. So we can say Spack install LibPressio plus ZFP plus SZ depends on SZ plus stats.
So Robert, I have a quick question here.
Yep.
Yeah, you run a Spack external find OpenSSL, and you said OpenSSL had been added to the system. What do you mean? It is not installation, right?
So what this is doing is we're saying that we're telling Spack that there's OpenSSL installed on Bebop for us. We don't need to install OpenSSL ourselves.
Mm.
So we're going to depend on the system provided version of OpenSSL.
I see.
Which means when we're building our list of dependencies, we don't need to build OpenSSL.
Mm-hmm. That makes sense. Thank you.
So this is a technique. This is a technique that can allow you to save a lot of time.
So you mean
the standard. So if we want to use the standard installed on Bebop, we just use Spack internal found the standard.
So in theory, you could do something like that, but the package itself has to support it. So I'm going to split my screen and we'll use my laptop to see if that's supported. So If you want to edit or view the package definition of any package, you can say Spack edit and then the name of the package. So this particular package has not been configured to be detectable with external find. So you would not be able to do this with Spack external find Z standard. It would be possible to modify the Z standard package to do that, but it hasn't been done yet.
I see.
If you want to get a list of all packages that support external find, you can say Spack external list, and it will present to you a list of all packages that support it. This process can be a little bit slow. My laptop has an NVMe disk in it, and as you can see, it's still taking a hot second to go through all of the packages and look for what's available. So this is the list of packages available for external find.
Okay.
Yeah, some of these, if you ever have to use them, it's strongly encouraged to use the external find capabilities. Good examples of this are Rust and LLVM. And the reason why I say that is if you try to build those yourself, they're going to take hours, if not close to a day. So this external find capability can potentially be quite powerful in helping you adapt to things that are available from the system.
I noticed Python also is in the list. So do we need to do the same thing for Python?
So you can use Python. My advice would be to avoid using external Python if you can help it. And the reason why I say that is external Python will try to find external Python libraries. And usually you don't have permission to write to the directories that you need to be able to write to if you have Spack installed Python libraries. Does that make sense?
I'm a little bit confused. Suppose I want to install the LibPressio Python.
Yep. So I'll show you how to do that in a second. But the important, okay, so I think it's import. I think it's, is it sys? Sys dot. Sys dot. It's not executable. Path. So your system is going to get path. It's called platform lib. So this platform lib specifies relative to your sys prefix where Python modules are installed. And if you're using a system Python, especially on an operating system like Mac OS, that may be on a read-only file system.
I'm using the Python from Conda environment.
Okay, that actually brings up a very, 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 very important point. Do not, under any circumstances, mix Anaconda and Spack.
Okay.
They both use very similar mechanisms in order to, they both use very, very similar mechanisms to manage dependencies. And what will end up happening is they will both kind of explode and neither one of them will work. So
Okay.
if you're going to use Spack, don't use Anaconda. And if you're going to use Anaconda, then don't use Spack. They don't mix very well.
Okay.
So the Python you're using is from the system installation or from the Spack?
Yep.
From the system, right?
Yeah. And
So,
on Linux, you can get away with using the system Python if you want to. The problem comes in is when you aren't using the system if you're using the system Python on Mac OS, because the system Python on Mac OS is not mutable. You can't change it.
so for the system installed Python, do you know how to add some packages to the Python if we need something else?
Yeah, so the general path that I recommend, and I actually do this for another project that I'm working on with Bogdan's group. So I'll show you what I'm doing there. So what I do in the installation script for this is I install Spack. We'll talk about environments in a little bit. This installs a Spack provided Python. And then I need TensorFlow. So TensorFlow is not a package that is provided by, it's not a package that's, well, it is provided by Spack, but it would take you days to build it. So don't build TensorFlow with Spack. But you can install it via pip. So the way to do it, if you need to do this, is that you would use your spack.yaml, and inside of your spack.yaml, you would include pypip and your Python version in your Spack installation. And then from there, you can then add packages like TensorFlow that you may need from outside of Spack. Does that make sense?
Thank you. Yeah, I think so, right.
So this Python is the external Python or the Python provided by Spack?
So in this particular case, it is Python provided by Spack. So I've asked Spack to provide me Python version 3.8 and a corresponding version of pip.
Oh, I see. Okay.
Okay. So one more comment that I will make on this installation script here is that the ordering is important. Once you have installed your dependencies with pip, you should not modify your Spack environment. So if you need to modify your Spack environment to install some additional software, the appropriate way to do that is to kind of start over from scratch and then just reinstall the Spack environment from scratch, then reinstall all of your pip packages. Does this make sense? Okay. Now, several of you will be using LibPressio from C or C++. If you're using if you're using LibPressio through C or C++, there are a couple of ways to get at the dependency that Spack has built for you. Okay. So first thing that we'll want to do is we'll want to see what versions of LibPressio that we have installed. So we can do that with the find command. Okay. You'll see that I have 3 different versions of LibPressio installed. Now, if I want to know what the differences between them are, I can ask for the list of variants that are associated with that package. So for example, I can see, I'm guessing, yeah, this one is using SZ3 and a Z. This one is not using either. So this is probably the one that I want. I can also ask for what's called the hash. Okay. So another way that you can load Spack packages is with Spack load. So once you've done this, you can use commands like package config. Has anybody used package config before? Has anybody used package config before?
I only use it for the standard.
Yeah. So you can use package config, and it will give you the include paths and the C++ flags that you need. And then you can also do the same thing with the library paths that you need to install and use LibPressio. So these are things that you could add to your make file, and then you're not hard coding how you access these things. If you're using CMake, there's an even easier way, because when you've loaded LibPressio, it sets this variable called CMake prefix path, and each colon delimited thing in this path are then discoverable via CMake. Okay, so you don't have to do anything else. You can just create a new CMake project. So I have a little helper script that does this on my computer. Or I can write it from hand. You can say CMake minimum required version. I generally recommend something after 3.18. You give it a project name. I'll call this one example. And then you can say find package, LibPressio required. And then LibPressio also requires std_compat. And then you can add your executable. So it's going to be called example. We'll call it example.cc. Target, link, libraries, example, LibPressio, LibPressio. Okay. And if we create a build directory, then we can ask CMake to build that for you. So if we then edit this, we can pound include LibPressio.h, and we can include IOStream, Pressio version. And everything builds and links successfully. Even though, if you look in my /include, or user include directory, excuse me, you'll see that LibPressio is not there. So 2 easy ways to build C and C++ things with LibPressio. You can either use CMake, and I can provide you this absolutely minimal configuration file that will show you how to link against LibPressio. Or you can use package config using the --libs and --c flags commands. Any questions on anything that I've showed off
Yes, for the CMake. So
Yep.
suppose I build a LibPressio with SZ. Can I
Yep.
also like use SZ from LibPressio?
Yep, you totally can. So now let's look at our example code real quick. There's a function called LibPressio, or Pressio, I think it's called supported. Okay, I'm going to set CMake export compile commands to on. If you've never seen this option before, this configures your CMake project to work with Clang tools. So C make. Now if we edit the example again, we have completion. And we see this is the list of compressors that were built with this particular version of LibPressio.
So we can like include the sd.hpp in the example file.
So you wouldn't actually do that. So let me show you how to then use it from here. So the first thing that you're going to use for LibPressio is you'll create a LibPressio instance. We'll call this library. And you'll say Pressio instance. And then you need to create a Pressio compressor. And we'll say Pressio get compressor. We pass to that the library. And then we can pass a string, in this case as Z. And what we would want to do at this point is make sure that we've successfully loaded as Z. So we would say if comp, so if the pointer is not null, we'll actually say if not comp, we'll say exit. And we can get an error message with Pressio error message on the library. And then we can pass that like so. And then once we have that, we can then configure the compressor. So for that, we're going to need a Pressio options structure. Pressio options new. And then we're going to want to set a setting on this option structure. So we could say Pressio options set double options. And then we need to give it a key. We'll give it the key Pressio abs. And then we can also give it the absolute error bound we want to apply. So we could say 1e minus 6. Okay. And then we need to apply those options to a compressor. Pressio compressor set options comp options. Okay. And if that does not return 0, helps to spell things correctly, but you get the idea. Okay. Now we have.
Okay. So we need to do this in the LibPressio way. Like, can we directly call the SZ compress API?
Yeah. So if you wanted to set SZ's absolute error bound, the other way that you could do this is you could say SZ abs error bound is that, and then you would set SZ error bound mode stir. And then you set this to set string. The first and the second group of things are the same.
I see. So
The only difference is this first guy works with SZ, ZFP, mGuard, any compressor that supports other things. As long as it has some notion of an absolute airbound, this is the setting that you're using. If you switch to SZ3 or QOZ, this is still the same option.
I see. Okay.
So I have a quick question. So yeah, you're using LibPressio option set double.
Yep.
So can I use float or?
Yep.
Okay, I see. Is it just the interface, right? Function, right?
Yeah. So it's probably worth at this point talking about what the actual. I'm just going to comment these two out. What the actual list of available options for a compressor are. So we'll create a new Pressio option structure, and we'll call it available. And we'll say Pressio compressor get options. And then we can pass in a compressor object, and then we can create a available string, and we will say Pressio options to string, and we'll say pass it available. Okay. And then we can print available stir. And then after that, we'll free available stir, and we'll Pressio options free available. We can also free the options here. The options that we use to configure the compressor as soon as we've called set options. Okay. So let's build this and run example. So here, starting with metrics : copy compressor results, all the way down is the list of all of the options available on the SZ compressor module and their data type.
Okay, so for the data type, for example, uint32, so how should I set the option? For example, should I use the Pressio set options int32 or just the int?
Okay, so let's go ahead and pull in C standard int. If for the C people in the room, this is standard int.h. So these two headers are equivalent. But once you have this header, you can create a uint 32t. So what's a good example of one of these things that takes a uint 32t? Max quant intervals. So we can come in here and we can say Pressio options set u integer like so. We can then pass it max quant intervals, and automatic conversions in C and C++ will automatically convert this to a uint 32t for us. But if we happen to have one, we can say something like max intervals equals 20, like so.
Okay, so if the data type is int32, then it is going to be set integer, right?
Yep.
Okay, thank you.
But the type has to match.
Okay.
So if the type that is specified is double and you provide a float, it's not going to work.
I see.
Okay.
Okay.
So now that we've done that, we probably want to pull in some data. So there's a couple of ways to provide some data. So you may already have an array that you've allocated. We'll call this from application. Okay. And if you're doing C++, you would say new. You could either say new float. What I would probably do is I would use a std unique pointer of float, like so. Std make unique float, and this is in the memory header. Maybe we want something that's 500 by 500 by 100, and we could use it like that. And let's assume, for sake of argument, that this is already populated with some stuff. We could fill it ourselves really quick if we wanted to. I'm just going to pull in something from the algorithms header. So we can say std iota. Maybe it's a numeric. And we can say from application.get plus 500 times 500 times 100 0, and that would fill that pointer with some data. You could also use a std vector. Like so. And for that, I need the vector header. Okay, and likewise, I could populate this with from the application. Some of the API usage simplifies a little bit, but it's basically the same idea. So if we have this data that's coming in from an application, the way that we represent this is with a Pressio data object. In both cases, we don't want LibPressio to free these things for us. So we can say from appback data, and we're going to create a new Pressio data new non-owning. And that takes a couple of things. It takes a Pressio float dtype to tell us what type it is. And then we need a std size t dims 500, 500, 100. And then we want to pass a pointer to the data. So from application vec data, and then we want to pass the array of dimensions. And then we want to pass the size of the array of dimensions. Okay. Target, compile features, example, std cpp 17. Sometimes I forget the order of these things. Okay, invalid conversion. Ah. Okay. Any questions on what I've done here? Std size of this is just 3. Okay. Once you have that, you'll need some data for it to decompress into, or to compress into. So we'll say compressed equals Pressio data new empty. It's going to be a Pressio byte D type, and we can just pass a null pointer for the size information. Okay. Any questions on what I've done here? Surely somebody has some questions.
Do you have a similar example in on the website?
Yes, so the website for GitHub, if we go to GitHub, Robert U94, LibPressio, the example here is basically what I'm typing up right now.
I see.
So these do very similar kinds of things. But there's also, you go to github.com, FTHPC, and then there's a LibPressio tutorial. And if you go to exercises basic C, basics.c is also doing basically the same thing. Okay, and I will put links to both of these in the email that has the recording.
Okay, thank you.
Then we can pass from application vec data and the compressed pointer. At this point, it's pretty key that we make sure that we don't get any errors. So we're going to check if this returns non-zero. If it does, we're going to output this information. Okay. Any questions on what I've done so far? So what we're doing here on line 54 is we are allocating okay. We can then do our decompression operation. Change this to decompress, change this to compressed, and change this to decompressed. Okay. Any questions so far? The last kind of key step here is you may want to get some metrics information from the compressor. The easiest way to do that is to come up here and set LibPressio metrics to be a string. So maybe you might choose size or time. And then we can come down here and we can say LibPressio options metrics results equal Pressio compressor get metrics results, pass the compressor. And then we can do the same trick that we did here. Metric stir, free, metric stir, see out, metric stir. Okay. So if we run this, I would expect that we're actually going to get a pretty large compression ratio. Oop, we got a seg fault instead. That's interesting. Oh, we need debug symbols. Great. If you ever need debug symbols from CMake, you can set this build type to debug, and then it will generate debug symbols for us. Compressed. We can even print this. So the compressed information looks fine. If we look at the decompress buffer, you see that we got an allocation. Pass the same information both times. Oh, we set the wrong type. Okay. So when you're providing a buffer to LibPressio, you need to make sure that the data types line up. So this needs to be a float. Now if we build, and then we run, we see that things run successfully. Oh, it's Pressio metric. So this is just kind of showing you what happens when you don't configure things quite right. It's not going to issue you a warning. It's going to ignore options that it doesn't know about, and that's actually in some ways for your good. But now we see we have timing information printed out for the compression operation. So we can see that compression took 633 milliseconds, decompression took 265. Okay.
So what data set did you use? I didn't notice.
So in this particular case, I just created one on the fly. So now we should probably talk about how to get a data set from something like SDR Bench.
Oh, I see. Mm-hmm.
So if we want to create one from SDR Bench, we would say Pressio data, and we'll call this one Hurricane. And we're going to make that a Pressio data new empty. We'll call it Hurricane metadata. And we'll give it a Pressio float dtype. And then we're going to pass dims.size, dims.data. And then we need to create the actual this, which we will Pressio data star, or not Pressio data, Pressio IO star POSIX, Pressio IO, or Pressio get this is in another header. Like so. And then we would say Pressio, POSIX. It's actually called library. Then we need to configure it. Options, POSIX options, new options. Pressio new, or Pressio options new, that's what it's called. Like that. And then this takes a Pressio options set string called IO path. And then on my file system, I have a copy of the Hurricane dataset at home, R Underwood, get datasets, Hurricane there, and then we can grab the Cloud 48 bin F32. So. And then POSIX options, Pressio IO set options, POSIX options. And again, you can check error messages on this as well. If Pressio IO set options, POSIX options does not equal 0. Do basically the same thing that we do here, except for instead of compressor, it's going to be called IO, and this is going to be called POSIX. And then once you've done that, then you can say that Hurricane equals Pressio IO read Hurricane meta. Okay. And then we can check for failure on this function. If Hurricane is the null pointer, then we can print an error message. And then when we go here, instead of from application vec, we'll set this to Hurricane, like so. We'll build it again, and we'll run it. This time, it took 543 seconds to compress and 273 to decompress. Now, if any of you have done C-based I/O before, you're like, oh my gosh, that is a ton of stuff in order to just get a file read off of the file system, and you would be right. The benefit to doing things like this is if you have an HDF5 file, you can just change this to be HDF5. Yeah, you can change it to be HDF5. And then you can add an additional option called HDF5 : dataset. And give it the name of an HDF5 dataset, and it just works. Or if you have NumPy data, you can read in files from NumPy.
That's interesting, but don't you need to install HDF5 beforehand?
Yes, so in order to use the HDF5, it's probably good to add a if statement here. If not POSIX, and then in here, you would say Pressio error message, and you'd pass the library instead.
I guess you also need to import the HDF5.h, right?
You don't actually. You don't. So all you would need to do in order to use this with HDF5 is when you install LibPressio, you would need to make sure that you got LibPressio plus HDF5.
Okay.
And if you wanted NumPy, it would just be LibPressio plus Python, I believe. I don't think there's a separate one for it. No, there is not. So it's just LibPressio plus Python. There are other formats as well. There's a format for if you do LibPressio plus CUDA. It may also be plus CuFile. Let me double check that. Yeah, so if you do LibPressio plus CUDA, and you have a new enough CUDA, you can even do CuFile-based GPU direct support. So while it seems like a bunch of extra effort, it does actually provide you some benefits for building your libraries this way and your applications this way, because then you can change out your data types and your file input formats as you need to. It's also not required if you're using a data type that supports it. Like, for example, HDF5 is self-describing. So if you're using HDF5 support, it's actually possible to leave out this metadata object entirely and instead pass a null pointer to the read function. So if you're using HDF5, you can set this to be null pointer, and then this would be HDF5, and then I have some HDF5 data sets, NIX here, NIX, H5 dump dash capital A, and I can see that it's called native fields. And then we can grab one of the native fields like dark matter density. And this obviously takes a hot second. It's seg faulted. That would be why. If you're doing this with data that you don't know what size it is, the easier way to do this on the decompress function is to ask the data that you're pulling it from what its size is. So you can say Pressio data num dimensions. In this case, it's going to be called hurricane because I'm lazy. And then for the dimensions, Pressio data, I believe it's called, you may have to copy it. So you would do size t ptr equals calc size t pointer size of size t and we want Pressio data num dimensions of them. I believe that is the right arguments to calc. It's been forever since I've used calc. Number of members and the size. Okay. And you could do it like this, and then to initialize each of these for I in Pressio data num dimensions, hurricane size t, you could say that PTR of I equals Pressio data get dimension hurricane and then I, and then in here you're going to use Pressio data D-type hurricane. So you're maybe thinking that seems like a lot. It kind of is. The other way that you can get here is you can say Pressio data, you clone hurricane. And as we can see, we have successfully compressed data that came from HDF5.
And it seems that you specified a particular data set inside that HDFI file to compress, right?
Yes.
So does that mean you actually didn't use the HDFI filter to do that?
That is correct.
Mm-hmm.
It's also possible to use HDFI filters. LibPressio does have HDFI filter support, but you can do more things with LibPressio's interface directly than what the current version of HDFI filters supports. Specifically, anything revolving around GPU-based compression is not going to work very well in the HDFI filters as they exist today. But I talked with some of the HDFI filter developers yesterday and made them aware of some of the problems that they have in their current API.
Mm-hmm.
Okay.
Okay. So so could you go back to the example file?
Yep.
Yes, you know, there are many lines already. So
yes,
I was wondering if you could, you know, go over the file again and tell us which lines are doing what things. You know.
Okay.
Mm-hmm.
So the first thing that you might want to ask when you're using this, or when you're using LibPressio, is what compressors, I/O modules, and metrics are supported. So that's what these lines do here. So this is just asking, what was my current version of LibPressio built with? Okay, any questions on that part? Going once, going twice. Okay. The next kind of stanza initializes a compressor. So in this case, we initialized as Z. This can be any compressor that's listed in this Pressio supported compressors call.
So what does this line do behind this command? You know what I mean? So for example, maybe it creates some memory or things like that.
Yeah, so in the particular case of SZ, this is equivalent to calling SZ init.
I see.
On ZFP, it's going to call, I think it's called ZFP create stream. So this is whatever function you have to do to initialize the compressor library to be ready to use.
Okay, thank you.
Okay. This next kind of stanza of things is how we configure the options that we care about on the compressor. And the important thing to remember here is we ignore any options we don't recognize or are the wrong type. Okay. You may be asking, why would you want to do that? What that allows you to do is write one set of options, one set of code that potentially works with a variety of different compressors. So if the compressor doesn't understand Pressio abs, it can just ignore it. It doesn't have to support things that it doesn't know about. And just as a reminder, these lines are equivalent to Pressio abs equal 1e minus 6 if using SZ 2. The equivalent set of lines for SZ3 are slightly different. Hey, David. Well, you came just in time for me explaining what's going on in this C example of LibPressio. So we have a number of Shane student on the line.
Sounds good.
Feel free to roll up a chair and
I will roll up a chair. All right.
Okay. So Shang, if you don't mind, I'm going to start over at the beginning of this file just to explain to David very quickly what's going on?
Sure. Go ahead. Mhm.
So these lines right here are C functions in LibPressio that let you know how it was built and what it was configured with. So you can ask what metrics, what modules, what I/O systems were configured when you initialized LibPressio. Okay. The next thing that we do is we create a Pressio instance, and that's how we're going to get access to these things. So it's how we get access to the compressors, how we get access to the I/O modules and metrics. The first thing we're going to do is we're going to ask for a compressor. In this case, we're asking for SZ. This is kind of like calling SZ init if you were using SZ directly. It's actually a little bit different though, and the key way that it's different is it's going to do reference counting. So SZ has a global init function, so there are potentially multiple copies of SZ that are being created. We want to make sure that we only destroy our instance of SZ once we finally are done using it on all possible threads. Okay. Then we want to configure the compressor. We can pass whatever settings that we want to pass to it. We need to make sure that the data type and the name match. Okay. And once we do that, we can then call Pressio compressor set options to configure the compressor. I also remarked that the Pressio abs key is equivalent to some additional set of keys in the underlying compressor itself. Okay. If you ever want to ask what compressor settings are available for any compressor, you can ask with Pressio compressor get options and convert the options to a string. So that's what we've done here, and then we're just printing it out with C++. I showed two ways to reference data that you don't control in LibPressio. So I showed how to do it with a std vector as well as a std unique pointer array, and how you can create a Pressio data non-owning data structure to provide a pointer to LibPressio with the associated metadata for these things that are managed by a different memory hierarchy. Okay. I also showed how to represent metadata if you're reading in data from disk. In this particular case, this information is less important, and the reason why it's less important is because we can also potentially read in from other data sources such as HDF5. And when we read in with HDF5, we just need to provide the I/O path, so the path to the HDF5 file, and HDF5 dataset, which is the path to the underlying data set that we're going to read. And then we can pass null pointer here for the metadata, and we can read that metadata directly from HDF5. There are reasons why you may still want to provide a metadata object if you are using HDF5. And the main reason here would be if you don't want to use a new allocation, if you want to reuse the same allocation for the buffer time after time after time for doing multiple read operations. I then explained how you create a location for the data to be decompressed into, and I showed how to copy the dimensions from the input data to initialize the metadata for the output location. Once you've done that, I've demonstrated how you can call compressor, compressor, compress, and compressor decompress to invoke the compressor, and then finally get metrics results from the specific compressor. And then I've shown how to free various things, but there are definitely some memory leaks in the example code that I've walked through today because I didn't do every free that I should have. But that kind of takes us through, at a high level, what are the kinds of things that are available in LibPressio. So David, do you have any questions, or?
It's just very similar to the Python LibPressio version. So, I mean, there's just a few more options you can add.
Yeah.
That's basically, you got to explicitly say some.
Yeah. And then the other thing that's worth mentioning to you, David, is this is kind of a minimum CMake file
Okay.
That would be required to use LibPressio. So you set the minimum version of CMake to something reasonable. So 3.18 is kind of relatively recent. So I think that's like the last 3 or 5 years. You give it some project name. If you have ClangD installed in your computer, the line on line 3 will set up ClangD to know about all of the types that are passed. Then you use these 2 commands to find LibPressio. You can then add an executable, and then you set that we're going to link against LibPressio, which will propagate most of what we need. And then we are additionally setting a minimum requirement on C++ 17 to build the software.
Okay. I'm guessing you use some features from C++ 17.
Yeah, so specifically, at one point in this, I used the std size function, but I since took that out. So std size was introduced in C++ 17. It is possible to compile LibPressio with C++ 11 and compilers as old as GCC 4. But then your application also needs to be compiled with the older compiler. So just make sure that the compiler that you're using for LibPressio is the same compiler that you tell Spack to use when you're building your software. So I think that takes me through everything that I've kind of explained up until this point this morning, Shang. Are there any questions that you or the other students have?
Yeah, I have another question. I don't remember which line you print the option for SZ.
Yep.
Right. So, but anyway, so my question is, I remember we can also do this using an executable, right?
Yes. So that's actually
that'll be more, right. That'll be more convenient to check the options, right? Mm-hmm.
Yep. So I started with the C code here because many of the students said that they were using C. But this is the code here that prints out the options that are available. So once you've created a compressor object, you can get the options from that object by calling get options. After that, you can convert it to a human readable string using Pressio options to string, and then you can print it, and then you should free both the string and the option structure that are returned to make sure you don't have any memory leaks.
Yeah. Okay.
So that's how you do that aspect. Now, the other thing that's important to know is LibPressio does not install the command line interface at the same time that it installs everything else. So if you want the command line interface,
Pressio options.
you need to install an additional package. So we'll say Spack install LibPressio plus SZ plus ZFP, just for example. And then we're also going to say that we want the LibPressio tools package. So LibPressio tools is the Spack package that contains additional information for installing LibPressio's tools. And this will probably trigger a recompilation of LibPressio because if you didn't, the LibPressio tools package requires some additional IO libraries that you may not have enabled by default. So it's going to trigger a rebuild here.
Okay, I have a quick question here. So it seems that you are at the home directory right now, right?
Yep.
So you're using source Spack demo share blah 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 to launch the environment. And how do we download the Spack demo, or is it generated automatically?
So Spack demo is just a clone of the Git repository for Spack that I named Spack demo.
Okay, I see. Mm-hmm.
So all you have to do is git clone http://github.com/spack/spack.
Mm-hmm.
Yeah, so you're not activating an environment. You're just activating Spack, and then you're just installing it globally on Spack, right?
Yep.
Because you didn't activate like a local environment.
Yep. And I skipped talking about activating environments because I'm working with a couple of students who this is the first time they've ever seen Spack before.
Okay.
So
That's fine.
okay. While we are waiting for this to install, I can show you what it looks like on my own machine. So what we can do is the command line utility is called LibPressio. And if you wanted to work with something like hurricane data, you would say LibPressio-I, give it the path. Yeah. Give it the dimensions. And the data type. And then we want to use a particular compressor. So we're going to use the compressor to be equal to a Z2. And then we can set that we want absolute air bound of 1E minus 6. Then we want to output some metrics, and specifically we want to output time and size information. And then we want to output all of the metrics that we received. Okay. And this is what it looks like to run this with hurricane data on my computer. Some of you may notice that there's some additional options that got printed out here in the metrics results. This is because on my local machine, I have ESE installed with ESE plus stats. So that's where these additional numbers are coming from. So you also may notice that in the C code, it was Pressio colon abs, but here it's just ABS. That's because any keys that you provide here that don't have colon or Pressio don't have a colon in them will be assumed to be Pressio colon abs or Pressio colon metrics. Okay, so you can also use this command line interface to do very much the same kinds of things. You can also use this command line interface with HDF5 files. And the way that you would do that is instead of passing a path to that, you could pass a file to an HDF5 file. Like so. And as I said, this part takes a few seconds, but we see that it outputs the same groups of information that we saw with the command line interface. Any other questions on the command line interface? One thing you may want to know is, how do I know what the options are called? You can use Pressio-A help, then you can give it a compressor ID, and it will print out human readable descriptions of each thing, its data type, and then a description for you to read to understand vaguely what it does. If you see what I would describe as a bug in the descriptions, they don't make any sense, let me know and we can try and lengthen the description that's used so that it's a little more intelligible. And I will put those 3 commands in the output as well, that are in the documents from this as well, so you guys have the examples of how to use the command line.
Robert, I have a question for the C++.
Yep.
Instead of the command line. So for the C++ file, if we include LibPressio in the CMake, that will include the SZ headers, will it or will it not?
So the SZ headers will not be available to you.
Okay.
But anything that you could do from SZ will be available from LibPressio. And the reason for that is that the way that I have instructed CMake to expose information on LibPressio, it does not propagate the include files or the include directories from the other libraries to the dependent library. And the main reason why this is useful is if you add new compressors, you don't have to recompile the user's application because the include directories and paths that it searches for that information have not changed. You just have to link with a version of LibPressio.
I see. So like, for example, if I have a function, utility function, as the header, I cannot use it if I import LibPressio as CMake.
So let's talk about that specific use case really quick. It's possible in this file to go in and say that I want to depend on SZ3. And then in here, you would say SZ3. I think it's SZ3 is how it's spelled. So that's going to require you to also load package config. And then that's also going to require you to do find, or I forget the exact syntax here. Find package config. It is called package search module. Like this. And then you would say z standard required lib z standard. And I know that just because I've looked it up. And then you also need to provide the imported target option to this function. Okay, and now your appropriate flags would get passed, Kai.
I see. So now I can use the function in SA3.
Yeah.
Okay.
Now, so my question for you is, what utility function are you wanting to use?
The read file.
Okay. So my advice would be to use the LibPressio functions for reading files. And the reason for that is that they will simplify if you ever need to read in data formats from other types of files, so like HDF5 or NumPy or things like that. But if you're looking for something simpler,
Yeah.
there are some other versions of these functions that exist. So for example, if you just call Pressio IO read with a path, there is another function in this function, this header right here, LibPressio ext IO POSIX. And instead of doing all of this stuff, you can just create the metadata and call Pressio IO data path read hurricane meta and then the path. And this just returns a Pressio data object. Is that any easier, Kai?
Yes, yes.
So for
Okay, in this way, I don't need the function as a.
yeah, and then here you would give it the path.
Okay.
You still need to provide the dimension information. But you're probably going to have to do that anyway.
Yeah.
And just so you can remember, that's in LibPressio ext IO POSIX.
Okay.
And then all of the rest of these functions are in the Pressio IO.h.
Okay. Thank you. I have another question regarding the version. So for specifically LibPressio version, it bounds to a specific SZ version, or we can adjust the SZ version.
Okay, so that's a somewhat complex question. So if you're using LibPressio, you'll see that there are a bunch of different compressors that are supported. Okay, and you'll notice that there's SZ and SZ3 as separate entries. There's also this particular one, there's QOZ, which is an extension of SZ3. So you can use all three of these together because they are different namespaced compilations of things. Okay, and you can even ask LibPressio what their versions are. So you can say Pressio-A version. And for all of the modules that it knows about, it will output the version number associated with it. Okay. Now, if you want different versions of SZ2, you would need to ask Spack to build that for you. So the way that you would do that is you would say Spack install LibPressio. You'd use the depends on operator, and then you could say SZ at 2.1.7, for example. And what that would do is it would build you a version of LibPressio that depends on this version of SZ. Now, on recent versions of Spack, it's possible to specify it this way. If you're using a slightly older version for some reason, you may also need to add this. And the reason for this is that this is a variant and this is a dependency. This variant requires this dependency, and we can provide additional information about it. But at this point, Spack is actually relatively intelligent in that if you ask it for this dependency, it will try to figure out what variants it needs to turn on in order to achieve that dependency.
Okay. So how does Spack know what the version list for SZ? For example, if I release a new version today, can I just install it in Spack?
Yep. So Spack has an archive of the tar files that exist.
Oh, I see.
But you can also register Git lists like so. Okay, so this will pull a particular Git branch. It's also possible to do this. And it will give you a version built off a specific commit.
I see. So who controls the version list?
Okay, so if you do Spack edit as E3, it will take you to the config file, and you can add entries to this file.
Okay, okay, I see.
Now you'll notice that it's pulling this from github.com robertu94 as E3 instead of as compressor as E3.
Mm-hmm.
And the reason for that is I usually do a little bit of QA before I update LibPressio, just in case you don't compile on some random system. So I kind of make sure that everything works, and then as you've known, Kai, I occasionally send you PRs with things to fix.
Mm-hmm.
And that when I update this version list is when this gets updated. And usually there's an email to you about that time with any fixes that I may need to make.
I see.
And if we look at SZ instead of SZ3, we'll see that there's a very, very, very similar piece of information for SZ2's versions. Okay. Okay. Any other questions from you guys?
Okay, I'm not sure if you already included it in, but maybe I missed. So could you tell us how to install some other compressors if we didn't do that during the previous command? For example, Spack install LibPressio plus IZ plus ZP, and then now I want to add the mguard into the package.
Yeah, so mguard is probably the most complex one to get installed. And the reason for that is that Spack as a technology has not yet figured out how to describe dependencies that depend on a kernel module. So specifically, mguard depends on the NVIDIA CUDA driver being installed on the system.
So this is not optional, right?
It's not optional.
Okay.
So most HPC systems will have that available for you. But because that version needs to be installed, not only do you have to have the driver available, it needs to match your CUDA version. So each driver version has a corresponding CUDA version, and those two have to line up. And then the last kind of big thing that you have to do is not only do you have to do those two things, but then you have to describe to Spack what set of CUDA architectures you want to build for. So for example, if you run the device query command, I am running on a A20 GPU on my machine, and that corresponds to CUDA device capability 86. So if you wanted to install LibPressio with mguard, you would need to say LibPressio depends on mguard, probably the development version, and then you're going to need CUDA, and then you're going to need CUDA arch equals 86 if you were running on my machine.
I see.
And then I may even additionally need to say that the CUDA version is 11 dot something because I am running a 500 series NVIDIA driver. So getting all of this just right with mguard is a little bit of a pain right now.
I see.
But it's doable if you need to do it.
So for example, if we just want to add the IPzip.
Yeah,
so
so
what do we need to
FPzip
do?
is way easier. So if you wanted to add FPzip, you would say FPzip plus SZ plus ZFP.
But you know, as I said, suppose we already installed SZ and ZFP, so we don't have to, you know, add plus at the end the ZFP again, do we?
Well, you actually do, and the reason for this is that what you're doing is you're also going to build a new version of LibPressio. And if I can type today, you're going to build a new version of LibPressio. So you're building a new version of LibPressio that depends on FPzip, SZ, and ZFP.
I see.
Because you could imagine that would be that maybe you do some different things, like maybe not with compressors, but if you had some other thing. What if this was include long double support, for example? Including long double support might change the way that you compile FPzip and SZ.
Okay.
But
in this way, did I install two LibPressio packages on my laptop?
Yep.
So how do I know which one I am using? Or can I delete the old one?
So you can delete the old one. That is something that is possible. But you can also leave the old one, and you can refer to the specific package by its hash. Okay, so this hash right here, you can say Spack. I'll wait for this to finish, but you could do Spack load /FYZQQFEI, and it would load this particular copy of LibPressio.
Okay.
And in that way, you can make sure that you get exactly the one that you need with exactly the set of dependencies you need.
I think there should be a command in Spack for you to check, you know, what versions are there.
Yes, so I will show you how to do that as soon as this finishes building.
No problem.
Okay, so this shouldn't take terribly long. It takes about 2 to 3 minutes. And it's already been going for a second or two.
Yeah, I think this is a very helpful tutorial.
Yeah.
And this is, in fact, I think this is not only a tutorial for LibPressio, but also tutorial for the CMake. Even
yes, so that was my point.
Okay.
That was my point in doing this, that I wanted people to see how all of these pieces fit together. Because like once you've adopted this whole ensemble of CMake plus Spack plus LibPressio, integrating compressors is easier than it's ever been before.
Yeah.
So David, do you have any questions or thoughts? You've probably seen some of this before in our research.
Yeah, basically all of it except like the differences between the Python and the C++.
Yeah.
The CMake, I guess.
Yeah, and probably the biggest difference for you has been that there's a lot more memory management stuff.
Yeah, so you gotta have more functions and free more stuff. That's basically it.
Yep.
Yeah, I just thought of another question, probably which are interested in to many students. So, you know, many people are using Python, right? So you just showed us how to call compressors in C++.
Yep.
So how about Python?
Okay, so for Python, what I'm going to do is I'm going to show you some code from the LibPressio tutorial, rather than code it all up from scratch, as we're talking through it. But you can go to exercises, basics, Python, and then this is what the high-level API for the Python interface looks like. So you're going to import LibPressio, and then you're going to create a compressor with this function. So LibPressio compressor from config. You give it the compressor ID. If you wanted to set up metrics, this would be setting up time, size, and air stat. This is very, very similar to what you would do if you were doing this in C++. And then you can pass the compressor configuration, in this case, the Pressio absolute airbound. And then instead of compress, because in Python, the kind of leading compression library that everybody uses is called numcodex. Numcodex, the compress method is called encode, and the decompress method is called decode. So I've changed the names in the Python interface to be consistent with numcodex. But that's roughly what it would look like to do everything that we did in C++ in Python. It's worth noting that if you're using the NumPy interfaces for reading files, the dimension order is flipped relative to what you would use for LibPressio and C and C++. And that's because NumPy uses row major ordering for dimensions. LibPressio uses Fortran style column major ordering. And while that seems out of place for C, virtually every compressor library for the last 3 decades has used Fortran ordering for columns, so I kept it consistent with all of the other libraries that have existed up until this point. So we have finished building LibPressio. So we can now ask what LibPressios are installed by using the find command. So we can say Spack find, and we can see all of the packages we've installed on our system. If we want to just look at LibPressio, we can say Spack find LibPressio, but this doesn't look very helpful to us. And the reason why this isn't very helpful is it just gives us the version. It doesn't tell us anything about the variants. So to get the variants added to this list, we will add -vl. V gives us the variance, and L gives us the hash that corresponds to that variant. So then we could say Spack load / this, and we've loaded this version of LibPressio, which we can see has fpzip turned on.
Okay, but I think, you know, this version is a duplicate a lot with the previous version, just at the, you know, IPzip, right?
Yep.
So my question is, why do you suggest me keeping the old version of the LibPressio installed?
So one reason to keep it installed is it's possible that you have applications or binaries installed with the old LibPressio, and you don't want it just to be deleted on you. So you've compiled some executable on top of LibPressio, you've written some CMake, and you've built a copy of it.
Yeah, I see. But
if it's for an old project, you may want to keep it around so it still just runs without having to necessarily rebuild everything.
okay, so if we do not have that dependencies,
yep, then you could
that should be fine,
uninstall
right?
the old one. So here's how you would do that. You would say Spack uninstall / that. And then you will see that this one has some dependencies. So if you wanted to remove this one, you'd also need to uninstall its dependencies. And you would add dependents like it suggests. And you will see that it'll remove 2 packages. And now they're both uninstalled.
Thank you. So you just created an example code somewhere, right? So that code will not be removed.
So the /temp examples code that we've built won't be removed, but the specific copy of LibPressio that it probably linked against was just removed. So I would expect that we would potentially, did I uninstall? I didn't uninstall that one. So if I uninstalled that specific one, like so, we would see that LibPressio is no longer found. Does that make sense?
Yes, I see.
So if we tried to run this, we'll get an error that says error loading shared libraries.
Okay, but we can just rebuild the package, right? I mean, example, right?
Yeah, and kind of the easiest way that you might do this is you might use what's called a Spack environment. So you can say Spack env create -d here, Spack env activate here, and then you can say Spack add LibPressio plus SZ plus CFP, and then you can say Spack install.
Yeah, so it seems that you are reinstalling the old version of the LibPressio, right?
Yes, but we could also, if we had a specific version, so see, because we didn't uninstall SZ or ZFP, it didn't rebuild those. It's only going to rebuild the minimum set of things that it needs in order to build the specific thing that you asked for.
I see.
And the benefit by using a Spack environment is twofold. So one of the benefits is that we now have this spack.yaml file that tells you exactly what you need to install this on a new machine. So this makes sharing code with other people much, much, much easier.
So how did you generate this spack.yaml file?
So when we said spack create -m, when we said this, it created the file, and when we called this, it updated it to include this.
I see.
And Spack install just refers to the YAML file and then installs whatever's in there, the specs that are in there.
Yeah, and when you call Spack install without arguments, after you've activated an environment, then it's going to use the spack.yaml file to be the list of things that it needs to install.
Yeah, so if someone shares you the YAML file, basically, like, it makes code sharing a lot easier, and you can just do Spack install and it'll install all the necessary requirements to run the code.
Yeah. The one exception to what David just said is you need to make sure that you all have the same set of package definitions installed. So for example, you would need to have the other person probably install the Robert U94 packages, the Spack packages repo that we added at the beginning of today, in order to have all of the dependency definitions when you need them.
So I have another question. So, you know, yeah, previously you just uninstalled our previous LibPressio package, right? And then that example kind of work because of the missing library.
Yep.
And so yeah, to solve that problem, we can just rebuild that code. And so I do know we have the new installed LibPressio package, which includes IPzip. So can we use this one to rebuild that code? To do that,
you could.
So should we modify the CMake list or something like that?
Yeah, so I actually uninstalled both of them.
Yeah.
But suppose that we wanted to use that version. You could do a Spack install -- reuse, and it will prefer to recreate your environment with the packages that are already installed on your machine if they haven't been requested. By default, I think it uses the minimum requirements to rebuild that. But the other piece of this is if you wanted to rebuild it, if we look in the CMake, it's going to have these _dir variables. Do we see those? So these _dir variables are going to point to the wrong location. And I have personally found it easier to just delete the build directory and rebuild everything after you've changed your Spack dependencies than to try and edit the CMake cache to have the right things in it. So now, if we do CMake -s -b /build, it'll say that it's missing SE3. That's because we didn't build SE3. But we can edit our CMake list, comment out that and then we also need to comment out that and then we can do CMake -build, and now we have a built copy of the executable, and we can do LDD build example, and we'll see that it's finding LibPressio from the environment that we created. And if you're curious, this path is a symlink to something that Spack has installed elsewhere. And the reason why that's important is you're not junking up your file system by having 70 copies of LibPressio by using this feature, because it's going to link to the authoritative copy that's installed wherever you clone Spack.
Okay, yeah, thank you.
Okay. Okay, so at this point, we've successfully built a copy on Bebop. We would say Spack load LibPressio tools, and we wait a hot second, and then it will load. So then we can call the LibPressio command, and we can see the list of things that it built for us. Okay. So any more questions on Spack, CMake, or LibPressio? Okay. Hearing none, I think it would be good to go around the room and have each person share one thing that they learned today and where they think they can use it in their research. So we'll start with David.
All right. So the reason I mainly came to this tutorial, one thing I learned was the C++ bindings for LibPressio.
Yep.
One reason I wanted to learn the C++ bindings was to make, I guess, our compression for my research a little bit more efficient. I've been using the Python bindings, but we're deciding to switch from Python over to C++. Because now we're caring about some efficiencies. So we initially used Python for the proof of concept, but now we want to make it more efficient. So
Looking at C++.
looking at C++ basically.
Okay, Sheng, you're the next one on the list of names. So what is one thing that you learned today and how will you use it in the future?
Yeah, I think this is a good question. So in fact, I think I joined this meeting mainly because many of my students actually are very interested in LibPressio because this is very convenient to do the compression, especially for some compressor. For example, mGuard. mGuard does not mGuard does not provide executable. So it seems that LibPressio is a unique way to do that. And also LibPressio is bound with some other tools like up2z config and the Thrive, right?
Yep.
So if we want to run those things, we have to learn LibPressio, and I think LibPressio is very powerful, and if we can get very familiar with that, that would be very convenient for the future research.
Okay. Yeah. What about you, Yanfan? I think you're muted if you're trying to talk.
Yeah, fine. We couldn't hear you, but maybe I can say something. Yafan is my student, and I asked him to join. And
okay.
Right, so for now he's working on on the RTM dataset, but I think in the future, anyway, LibPressio is very convenient too. So any of my students should be familiar with this tool. So I just propagate this good news about the tutorial to other students and ask them to join if they are available. Right.
Yeah.
Mm-hmm.
Yeah, I appreciate you kind of echoing that, Sheng. I was just trying to make sure that I use this question as a tool to make sure that people understood or took away at least one thing from the talk. So if students don't want to answer or don't feel comfortable, obviously they don't have to, but it would be better to hear from the students directly.
Hello?
Yep.
Dr. Robert, can you hear me?
Yep.
Okay. Thank you for your interesting and useful talk and tutorial. Thank Dr. D for invitation. I'm a student. I will work for Dr. D about the compression gradients. And now I am conducting an experiment on different on the gradient using different compressors. But right now I need to know about I need to know every compression, how they works, how can I configure their parameters. But right now I think with the LibPressio, it's very convenient. I just need to configure every parameters in the LibPressio. So yeah, I think this is a very important scenario for me, right, Dr. D?
Yep.
Yes, exactly. Right.
Yeah.
So yeah, we need to check different compressors, and for now, I think you already test the results by running the compressors at the qubit directly, right?
Some of them, not all of them, but I think for the rest, I'm gonna use the
Okay.
LibPressio IO. Yeah.
Yeah. Okay. Sounds good.
Okay. Thank you, Robert. Thank you again.
No problem.
I can share something that I learned from this lecture. So I think it's a very powerful tool because in our new project for progressive compression, I think the LibPressio IO can help me to switch more conveniently between different different compressors, and I think that's what we are intended to do with this this project, the progressive compression, because we want to use different compressors in different stages and and even for different precisions. So with this framework, we can conveniently implement our ideas. Thanks. And Dr. Underwood, can you share the code in your example folder?
Yeah, so I will share with everybody the code that I did today, a link to the complete LibPressio tutorial, as well as the example command line things that I showed you guys as well. So you will have the link to the tutorial, you'll have the link, the code sample that I wrote up today, and then the 3 command line examples that I went through.
Thank you very much.
Okay, Kai?
Yeah, in fact, I have 2 more questions.
Okay.
So, like, can I include 2 different SA3 versions in the same time in LibPressio?
So you can include QOZ and SZ3 at the same time, but you can't include 2 separate versions of SZ that aren't named differently.
I see. I was asking this question is, I think LibPressio can be a good tool for us to write the paper, because if we design a new compressor, we need to compare our compressor with several benchmarks, such as SA3, SA2, FP, and the FP. If we can use the LibPressio to run all the compressor and generate the result, and then maybe plot some figures, that would be great.
Yeah, and actually, I didn't show you how to do this today, but it's actually possible to use what's called the external metric, and you can use that to call down to GNU plot or matplotlib and have LibPressio, as it's running, generate your plots for you.
I see. So that's great.
So if you want an example of how to do that, there's an example in the LibPressio tutorial that shows how to do that with matplotlib and Python.
Okay. So, for example, I still want to know, is there a way I can evaluate my new compressor? For example, I modify the SA3, but I keep the API the same.
Yep.
How can I evaluate my compressor together with SA3?
Okay, so the easiest way to do that, and this is what I did with QOZ, is in the QOZ repository, we made a couple of changes. So one, I made sure that everywhere in this file, it was called QOZ instead of SZ3. So that was the first change that I did. And then the next change that I did is inside of these include files, I added a namespace. QOZ API SZ.hpp. Yeah, so I added a namespace. And this namespace that I added calls things QOZ : instead of SZ3 : so by doing that, they have unique names. And the reason why that's important is if you're referring to different compressors, you need to be able to specify, you need to have unique C binary names to call the functions. So if you, for example, use object dump, I think is the easiest way to obg dump. Local include or not lib 64 lib z. I think it's called, is it -t? You see all of these names. So in C, they're actually relatively easy to read. But if you did the same thing with QOZ, it would have a very different name. So the important point is that you would, I can show you with LibPressio. It'll have what are called mangled names, but the important piece is that the mangled names need to be unique. So by adding a namespace, you can ensure that the names are unique. And then once you've done that, you can go into your installation of LibPressio, and in the source plugins compressors, you can copy SZ3 and then call it source plugins compressors new SZ3. And then in here, you'll change this to be new SZ3 or whatever you call it. And then in here, in the prefix, you're going to change it to whatever your new SZ3 is. And then you also need to change it here. So those are basically the places where you would apply your changes.
I see. Okay.
And if you want to do that, Kai, we should probably have a separate meeting where I walk you through it the first time.
Okay.
The last piece that I will mention in conjunction with this is if you have a Spack environment, that you've activated, you can say Spack develop LibPressio at master. And what this will do is it will clone a copy of LibPressio for you. And then you can make your changes in this copy, and they will be reflected when you call Spack install.
I see.
But again, that's one of those things that's a little more advanced. So we probably shouldn't go through that today. Okay. Any other questions, Kai?
Yeah, for this Spack environment, so since those environments are isolated with each other, like, can I create two environments? And for the first one, I use SA3, standard SA3, and for the second one, I use my new SA3. So
yeah, you could definitely do that. The other thing that you can do related to that point is, let's say you added a new SZ3. You could say Spack edit SZ3, and you can just add your new version here. So if your version is on a branch, you could say develop, and then you could give it branch equals my new branch. And it will, whenever you, and then you can just say build me LibPressio, Spack install LibPressio, depends on SE3 at develop, which corresponds to your special branch name.
I see.
And that's probably even easier.
Yeah.
And then to switch between the environments, you would just say Spack env activate path to the spack.yaml directory. Does this make sense?
Yes. Regarding this environment, so I cannot use it together with Anaconda, but I can use it together with the module load, right?
Provided that you've made the correct entries in your Spack packages configuration to let it know that you need to load the module.
Okay.
And when I do that, I usually have a setup.sh file that I create because Spack will not do the module loads for you. You need to do those by yourself. So then I usually do module load, the packages that I need to load from modules. And then on the next line, I load Spack.
Okay, I see. Okay, thank you. That's all my questions.
Okay. I hope this has been useful for you.
Yeah, yes, very useful.
Okay. Well, that said, we have gone a little bit over the time that I originally scheduled for this, but I think we had some good discussion and some good questions. So if no one else has anything else, I will wish you all a wonderful day, and we will call it here, and I will send a follow-up email in probably 20 minutes with the materials that I mentioned.
Okay, thank you. I appreciate that.
Thank you. Thank you very much.
Okay.
Thank you. Thank you very much.
Thank you. Have a good day.
Okay. Bye, everyone.